Hey guys, Dr. Betts here. We're going to talk about Unit 2, Scientific Measurements. Very important topic in chemistry. It's important that you learn how to measure properly. Now, there's two different types of measuring devices, analog and digital. Analog has different rules than digital. Digital's rules are very simple. Look at what the digital device gives you, read it off the display, write all the digits down with a unit, and you're good. Analog's a little different, so let's get into it. All right, so before we get into that, outline, part 1. 2, and 3, a student will learn the proper method for reading analog measuring devices, such as a ruler and a graduated cylinder. So you're going to learn how to use both today in today's experiment. Scientific measurements, outline, part 4. Student will learn how to use a digital balance. Very simple. One of the easiest things you'll learn to do in all your life. Very simple to use a digital balance. And part 5, a student will learn the proper methods for graphing scientific data. Very, very simple, guys. No problem at all. Part 1 and 2, 2A, measuring length with a ruler. Now, to measure length with a ruler, you have to first look at the ruler carefully and examine the graduations or the tick marks on that ruler. The tick marks are things that are usually they're black and sometimes they're red or green depending on the manufacturer. You have to examine it and say, okay, every tick mark means this. So let's take a look at this one here. This ruler, every tick mark that's written on this ruler is 1 centimeter. The unit is right over here. Usually print it in the bottom left-hand corner. Sometimes it's printed somewhere else, but usually bottom left-hand corner. I know that this black line is greater than 2, but less than 3. And there's no graduations between these two. So my smallest unit of measurement on this ruler is the 1 centimeter. So I have a lot of confidence that this line is 2 point something. We don't know where it is. There's no number written to tell us what the point is, what the first decimal point is, but we can estimate it. So I'm going to say that this line is 2.5 centimeters. Now, let's be careful. This number I got from the device. This number I estimated. It's called the estimated digit. I literally made a guess at it. You might have said 2.6, maybe even 2.4 or 5. All those are correct. It's this number that you measure from the device. You can get it directly from it. This one you're estimating using your mind's eye to kind of figure out if there were graduations here, what would it be? Okay? Let's go to the next one. Now this one here has a lot more graduations, has a lot more going on. So we're going to be a little bit more careful here. Every one of these large graduations is 1 centimeter. Every one of these small graduations or tick marks is 0.1 centimeters. So this device can measure with a little bit more precision, more decimal points, if you will. So here I know that this line is greater than 2, less than 3. So I know it's going to be 2 point. Now on this ruler, we can kind of see the tick marks, right? They're right here. 1, 2, 3, 4, 5, 6. So this line appears to be a little bit greater than 2.5. A little bit less than 2.6, so I can put 2.5 centimeters. But now we have to have the estimated digit. Remember, every analog device has to have an estimated digit. You have to go 1 digit beyond what the device can measure. This particular ruler, the bottom one, can measure to the 0.1, to the 1 decimal place. You have to estimate the second decimal place. So here I'm going to say it's probably something like 2.55 centimeters. This is my estimated digit, and these 2 digits I got from the ruler. I just read it off the device. All right? And that is how you measure with a ruler. All right? Here, this is a graduated cylinder. Graduated cylinders are generally used for measuring volume, pretty much all the time. So let's take a look at this. Now, when you're using a graduated cylinder, you have to look for something called the meniscus. The meniscus is this curved line right here. Now, when you're measuring liquids from a graduated cylinder, you have to measure from the bottom of the meniscus, which is why on this zoom in here, the artist drew in these 3 dots to indicate that your eye should go to the bottom of this meniscus. Now let's look at what every one of these graduations mean. This is 60 milliliters. That's 70 milliliters. So the big tick marks represent 10 milliliters. The small ones represent 1 milliliter. So this is 61, 62, 63, and so on. So it appears that this volume is 61, 2, 3, 4, 5, 6, 7, 67. Now be careful, I can read the 67 from the device because this device is measuring to the ones position or to the 1. So 67 is good, but we have to estimate the next digit in the series. The device's smallest increment can measure 1 milliliter. We have to estimate the next digit in the series, which will be the first decimal point. So I'm going to say this is 67.0 milliliters. All right, again, this digit I got from the device, this digit I got from the device, and this digit I estimated. The meniscus happened to fall directly on the graduation, so I put 0.0 to indicate that to the reader, that I measured this volume to this precision. This is my estimated digit. Every analog device must have an estimated digit. There's no exceptions to this. Measuring mass. Now, using a digital scale is easy. It's great, actually, to measure with a digital scale because the scale does all the work. The manufacturer has programmed the scale to give you the estimated digit. You don't have to do anything. Just read the scale. This particular scale, you just turn it on. You hit the read 0 button, the little red button, if you need to, and you place whatever you want on the pan on the inside of the housing. This fancy housing here, this thing here, is designed to prevent airflow over your sample because these scales are so sensitive that even air or even a little bit of vibration of the table can throw them off slightly. So that's what this is for. And you just place your object on the digital scales pan and read every one of these digits and the unit. So for this one, of course, it's 2.942 grams. I would write all of that onto my data sheet or into my notes, however I'm doing it, so I can keep track of it. Okay? But a lot of students, and I don't know why, will take the digits from the digital scale and they'll round it to the first decimal place. Don't do that. School paid a lot of money for these scales, so let's use them to their full potential. Lastly, but not least, graphing data. Now, in your experiment, you're going to be using the mass and years of coins, pennies to be specific. But I'm going to show you how to do a graph just using some heartbeat data. No problem. So on the x-axis, which is the axis that runs left to right, this is the x-axis. We're going to write time. We're going to put the time increments down there. And in the y-axis, the one that goes from top to bottom, we're going to write heartbeats, so the number of heartbeats. So we have to be very careful when you're doing measurements because you have to do what's called scaling. Every square has to mean the same increment. Okay? So we're going to put time along the bottom. So let's say we start at 0 here, so 0 time. Half a minute, minute, minute and a half, 2 minutes. 2.5 minutes, 3 minutes. 3.5 minutes, 4 minutes. 4.5 minutes, 5 minutes. So every square represented 0.5 minutes. That's good. So and it fit nicely on the space provided. So let's write that in. Put a 0 here. Put a 1 there. 2, 3, 4, and 5. Now notice how I didn't write anything here. That's for neatness sake. I didn't want to crowd up my graph by putting in a lot of numbers, so I just left this one blank. But you can tell it's a 0.5 because you go from 0 to 1, so that must be 0.5, 0.15, 0.25, 1.5, 2.5, 3.5, and 4.5. And this is time, and it's in minutes. Okay? So I put the label on my graph. It says time in minutes. So the reader can tell what time increments, what these numbers mean at the bottom. And so now they know it's time and they know it's measured in minutes. On this y-axis, now we need to put some data. So our data starts at 75. So we can probably start, say, at 70. Let's say this is 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130. So we can go all the way to 130 on this, counting by fives. Every square is 5 heartbeats. Look at our data. Our largest number is 122, so that's plenty of room. It's actually going to be a fairly nice graph. Let's use red ink. So this will be 70, 75, 80, 85, 95, 105, 115, 125. And we can stop there because our highest measurement is 122. Okay? So now we need to do some graphing here. So let's graph the first minute. At time 1 minute, we have 75 heartbeats. So let's take a pen, make it, how about magenta? So time 1 minute, go up the line, find 75. 75 is right there. So we need to put a dot right there. There we go. I made it fairly big so you can see it on the video. You can make yours a little smaller. Next, time 1.5. It's right here, 85. So now we have to put a line here. Or sorry, pardon me, a dot here. There we go. Time 2 minutes, which is right here. 100 beats per minute. So now we got to go a little higher. So there's 100. So it's 95, 100, 105. So 2 minutes, put a dot right there. There we go. Now we got to go to 2.5 minutes. 115, right there. Let's put a dot right there, 2.5. 115. 3 minutes. 120. 3.5 minutes. 120 again. 4 minutes. 122. So slightly above the 120 mark. There's no line that indicates 122, but we know it's between 120, come here, 120 and 125. We know it's somewhere in there. So let's put it in right there. Okay, and I kind of just had to guess approximately where it would go. I knew it went in there somewhere, so I just placed it there. And there you go. There's how you graph scientific data using chart paper or graph paper and your pen or pencil. And that's how you do it, guys. The big trick here is to remember to label, for one thing, to label your axis. Let me do this here. Heartbeat. Forget to do that. Heart rate, I guess. Heart rate, and that's in beats per minute. There you go. I almost made that mistake. Good for me. Remember that every square going to the left and right and top to bottom has to mean something, has to mean the same increment. Now the x-axis increment can be different than the y-axis, like it is here. Here it's half a minute, and here it's 5 heartbeats. That's no problem, but it has to be 5 heartbeats all the way up and half a minute all the way across. Every square has to represent the same value going left to right and the same value going top to bottom. But again, those values could be different. The x-axis and the y-axis could have different values, and often they do. All right, now that's the end of this video, and I want to wish you all good luck and good chemistry. We'll see you soon.